Orbital refilling, also known as in-orbit fuel transfer, is vital for Moon and Mars colonization. So how does it work? What are some of the possibilities and some of the difficulties? This is what we're going to have a look at. On Earth's surface, because you have a gravitational field and you have a solid Earth, therefore you have a reaction force which allows the fluid to flow. However, in orbit, though there is gravity, there's no effective gravity between the fuel and the ship. So therefore, when we want to pump from the supply tank to the refilling tank, we have a problem. We have generally mixed phase and we've got it floating around. Using a pump is almost impossible to be able to get the fluid transferred. Therefore, method one is known as pressure differential, sometimes called static pressure and differential. And what we can do is that we can actually heat the supply tank and cool the receiving tank. This causes a pressure differential which allows the fluid to flow. Now, one of the problems is we often have to vent out of the receiving tank to lower the amount of pressure. This also can be done passively or actively with cooling and heating. Now, in reality, what we tend to do with it is we use induced or artificial gravity. What we mean is settling thrusters. And what this does is you provide a steady amount of thrust which causes the fluid to settle to one side or to one end. And that's the end where you actually have your transfer tube. Now, in reality, we usually have this in combination with pressure differential. So therefore, you get a fluid transfer, not just gas, mixed phase, etc. Now, one of the major drawbacks with this is you end up burning a significant amount of fuel to be able to have these settling thrusters firing. And it needs to actually fire pretty much for the whole time that you're doing the transfer. Small amount, not a problem. A large amount could be a significant amount of time and hence fluid burnt. The third method I'm going to call the syringe. And what this literally does is that you have a cylinder which has both valves, and we open the valve to the supply tank. We then pull the cylinder or the syringe. When that pulls a significant amount of fluid into there, then what do? We close the valve to the supply, open the valve to the receiving tank, and then we push. This is a transfer method. It would probably need multiple actual pushes and pulls, and there would be some issues perhaps with the pressure. You might again need to vent out of the receiving tank to be able to provide the right amount of pressure differential to be able to easily transfer the fluid. This has never been tried before, as I understand, and would require a significant amount of testing. Now finally, what about other methods? Well, one method that is interesting is to have induced gravity, sort of gravity, via circular motion. So that means that you get everything moving in a circular motion, and what will happen is, again, the fluid will settle to the outside, or what could be the bottom, again, where you have the transfer tubes. Now, the benefit of this is once you actually use your thrusters to get in motion, it continues to provide that settling effect without a continuous burn of thrusters. Drawbacks. When you transfer fluid, you will change the center of gravity. And the center of gravity affects how it actually spins. So you could have some rather eccentric variations in your spin. Also, you will have a transfer. When you have transfer of fluid, you will actually have a change of momentum. That means there's an equal and opposite change of momentum with the ship. This could also mean that you have some very unusual changes of momentum both linearly and angularly in multiple orientations. This means that you might actually have some difficulty with control, and you might actually have to fire a significant amount of thrusters to be able to hold the ship steady in a uniform circular motion. Now, I hope this helps you to see some possible methods. There could be other methods as well. It just sets out what is possible and what we might see in the near term.